Hi, John McElroy here talking all things automotive. You know all this talk about AM radio not working in electric cars? Well, maybe the car companies really don't know what they're doing, because Joanna McLellan here says she's got a solution, not a solution, knows how to deal with all this stuff. And Joanna, what I love is you refer to this as radio frequency spectrum pollution coming from these electric motors and inverters.
We are creating an amazing amount of electrical noise from electric vehicles. And there's no real necessity for us to do it. It's happening because the engineers don't understand the physics. It's like sending lambs to a slaughter to say, okay, you've got a BSEE. We want you to design something that will pass the EMC test. It's not going to happen unless you give them some very specific training, and they have to understand the implications of the pesky slow speed of light.
Mm-hmm. And we'll get into this later. Right now, we're talking about AM radio.
Yes.
But you're saying this could affect police radios, fire, ambulance as well?
Yeah, there's some really serious side effects of all of this. If your ambulance or police communications gets disturbed because you're driving a noisy electric vehicle, this is really bad. There's all sorts of bands that are being used by an amazing amount of people to do all sorts of stuff. Everything from, we have smart meters on the side of our house that talk on the cell phone network to give us a cheaper rate on our electricity. Well, those things are radios. Right now, there's radios and thermostats. If you disrupt that communication, your house isn't going to be controlled correctly.
What I love, you describe electric cars as noisy. You're talking about electromagnetic noise.
Electromagnetic noise.
What causes that?
You have these great big massive transistors with what we call an F sub T, which is where the gain of the transistor goes to unity. And that F sub T is very high. And so it slams from a high voltage rail down to a negative voltage rail. And it does it so quickly that it's creating RF energy in that edge.
RF being radio frequency.
Radio frequency energy. And the problem with radio frequency energy, it's different than what most people think of. When you have DC current, the current stays in the wire. The energy stays in the wire. But when you have an AC current above 100 kilohertz, the energy starts to travel around the wire, not in the wire. So it's a fundamental difference in the way the energy travels below 100 kilohertz and above 100 kilohertz. And that's where people get in trouble, because the energy leaks out of the wires and they don't know why. It's black magic. It's mystic. No, it's physics. And if you understand the physics, it's easy.
So if I look at an electric motor in an electric car, the AC wires are those big orange cables coming out of there?
Oh, they're disgusting.
But that's one of the big sources of all this electromagnetic radiation, right?
Yes, and I'm going to try not to get too deep in the weeds here.
Good, because I can't understand it anyway.
Okay, so when you have a forward current, okay, the positive wire, and you have a negative current, the negative wire. And so you're sending current out and it's coming back on the negative wire. Okay, well, from an electronic point of view, when you have a very fast switch, what's really happening is that you're sending a wave of energy down both the positive and the negative wire at the same time. That energy flow is flowing at the speed of light, or some fraction of the speed of light. And that's why I call it the pesky slow speed of light, because if it was just an order of magnitude faster, our lives would be a lot easier. But it's not. It's finite.
So why is this electromagnetic interference disrupting AM radio?
It's like lightning. Okay, you have a large current moving through space, and that creates an electromagnetic field. That lightning has got a very fast edge to it. And it's the electronics in the PWM of the driver for the motor has that, very similar, very fast edges. To make those very fast edges, you have to have RF energy, and that RF energy is leaking out of the wires.
So you're right, because if I've been listening to AM radio during a thunderstorm, every time there's a bolt of lightning, I hear crackling in the radio. And so what you're saying is it's the same effect. It's just coming out of the electric motor or the inverter.
Same thing. Now, there's a couple of things that makes it even worse for an electric motor, and that is people think of an electric motor as just a really big inductor. Okay, but they don't think about the parasitic capacitance between the windings and the stator. So you take all these wires and you wrap them around the stator, and you unintentionally form a very large capacitor. So if you look at that capacitance, there's something on the order of 20 nanofarads of capacitance. So you're slamming these massive transistors with a massive EPS of T that are very fast transistors into a 20 nanofarad capacitor, and you're having amazing levels of current going through that capacitor. But what is that capacitor? That's the distance between the wires and the physical metal of the stator. And so now you have a massive current, and that current has got a lot of RF energy in it, and it's going to leak out. They changed the bearings from metal bearings to silicon nitride bearings, because the silicon nitride is non-conductive because the raceways wear out.
No, well, let's go back a little bit.
Okay.
So you're talking about the bearings in an electric motor.
Yes.
That the stator rotates on.
Yes.
Or the armature rotates
Those
on.
bearings, if you look at them, they have the tendency, if you use a steel ball, to get this really odd pattern of arcing in it. And that odd pattern of arcing is the RF energy trying to get out of the motor. So their solution is to use a non-conductive silicon nitride ball, which is the kind of balls in the bearings that you use in Formula One vehicles, because it can stand the temperature. But you're not using it for the temperature. You're using it because they're non-conductive, and they don't help the RF arc into the raceway of the bearing. Same thing happens on windmills and also on big motors in factories that are controlled by pulse width modulation.
So let me make sure I understand this. So you've got the armature, and you've got all this energy leaking out. It's going through the bearings. It's pitting the bearings. I mean, it's
arcing between the balls of the bearings and the raceway of the bearings,
which will cause the bearings to fail at some point,
yes.
Right? So you're saying they're putting in non-conductive bearings as a solution.
Yes.
But you're saying it doesn't really solve it.
Well, it solves the problem of the bearing dying, but then it makes the EMC even worse, because now you have the RF currents coming out the half shafts.
You mean the shafts coming out of the motor are now
yes.
radiating even more energy?
Yes. And so when that shaft hits a quarter wavelength, it makes a wonderful antenna. And so what it all comes down to is how fast does the energy move, and that's a fraction of the speed of light. When you have a young electrical engineer learning how to do electrical engineering, they're taught in circuit theory that there's this thing called ground, and it's omnipotent. It is most powerful. It is absolutely amazing, because you can have a plane of conductor, and you're going to call it ground, and there's a voltage here, and you say that this voltage over here on the same conductor is the same voltage at the same time. Buzz, wrong answer. All right, to get from here to over here, it takes time because of the pesky slow speed of light. So 11.8 inches is the speed of light at 11.8 inches per nanosecond. And so that's how I express the speed of light, because it makes people understand that if this is ground here, this is not ground over here. It is 1 nanosecond, 2 nanoseconds, well, maybe a little over 2 nanoseconds away. So it's not at the same potential. There's a phase delay. And that's what causes young electrical engineers to think of radio frequency work as black magic. But it's not black magic. It's just physics.
Automakers want to get rid of AM radio because of this problem,
Oh.
but also because the way that they're trying to solve it, they're using all kinds of filters and shielding and capacitors, right? And you're saying you don't need to do that if you do it right.
They have it backwards. Okay, what's the first thing that they look for? They say, you got to put a shield on it. Okay, no. The last thing you do is to put a shield on it if you absolutely have to, because manufacturing will hate you for it. They will throw rocks. They will, it will not be pretty. And so stop thinking shields to begin with and start thinking about resistance to begin with. A lot of the energy is occurring because there is a resonance structure being built. You remember the Tacoma Bridge?
Mhm.
Okay, and the Tacoma Bridge is undulating and the whole thing just falls apart. Okay, well, in electrical engineering, it's the same stuff. And so you get a resonance forming, and at that resonance, you have very high currents moving back and forth between the capacitor and the inductor. Those high currents make for high fields. And so if you add a series resistance or a parallel resistance, depending upon the circuit, you can fix most problems. And they're cheap. I mean, a shield is hideously expensive, and a resistor is cheap. But they use the shields first, and they don't think about using the resistor. I mean, for instance, you take a bearing, okay? There is a structure there. It has a physical length, and so hence that physical length implies an inductance because there's phase delay in that length. And so if you put a resistive coating in the right place, you can lower the Q, is what we call in electrical engineering, the quality of the circuit. It is a measure of the resistance in the circuit. And if you have a high Q, you have a lot of energy in it. And by putting a resistor in the right place, you lower the Q of the resonance structure and kill the EMC problem.
So what you're saying, if you design it right from the beginning, you can solve this pretty inexpensively. And
it's very inexpensively, sometimes, pennies on the $100 bills when it comes to doing it at the end. And that's where it really gets ugly. So if you don't address EMC right at the very beginning, if you don't think about EMC at very, very beginning of the program, then tooling gets set. And as an electrical engineer, you go up to a mechanical engineer saying, hey, your tooling for the heatsink is all wrong. We have to fix it. And he looks at you and says, I've left that contract. It's out the door. Too bad. Live with it. And as an electrical engineer, you can live with it. It won't work. And so you fail the EMC test.
so why don't automakers do this right from the get-go? And I mean, we're not just talking the legacy automakers, right? I mean, Tesla was, I think, maybe the first to drop AM radio. Even the geniuses out in Silicon Valley are not getting this right.
No, it's the education that the electrical engineers get. It teaches them how to fail because of this issue of ground, this omnipotent, most powerful thing called ground that doesn't ever exist. There's no such thing as ground above 100 kilohertz. It does not exist. But the engineers thinks it exists. They're trying to understand, the physics with this omnipotent ground that doesn't exist. And so they get into trouble. They can't understand it because.
So you're saying the mechanical engineers don't get it, or the electrical engineers?
None of them do. And in fact, surprisingly enough, it is the mechanical engineers that hold the key to solving EMC problems. And the reason for this is that the shapes are critical in the EMC frequencies where they have failures. For example, okay, you have an FM band. You have a 1 meter wavelength. So you have to think in terms of what's near a wavelength. If it's a loop, if it is a rod, like I was mentioning the half shafts, you've got a ground on one side, you've got an open on the other side. That's a quarter wave antenna. So quarter wave, where does that come from? That's the wavelength of the frequency that's trying to sneak out of that antenna. It will come out the best where that antenna has gone self-resonance. And that's where the EMC problems mostly line up. Now, occasionally, particularly with electric vehicles, you have so damn much power that it comes out in other places other than in resonances, but it'll come out the best at the resonance structures. So if you look at the spectrum in a linear frequency mode, not a log scale, okay, it's one of my pet peeves. They hand me data. The data is in dB versus log frequency. Harmonics is a linear issue. It is not a logarithmic issue, but yet we display the data, we try to figure out the data in displaying the log frequency. It's just dumb as a rock. Plot the data out in linear frequency and you will see the bumps. You will see the resonant frequencies and you can go in and recognize them because of the physical shapes and you can fix the problems. Easy, quickly.
So what do we need in our education system then? Well, how do we train engineers the proper way in being able to design these systems?
That's really difficult because as far as the educators are concerned, I'm a barbarian. I am saying that their baby is ugly, that the way they teach circuit theory is teaching people how to fail because of the way they say that there's this omnipotent ground out there. It works great at DC, but it doesn't work above 100 kilohertz, and that's what has caused the black magic to occur.
What about within the car companies themselves? Do they have to reorganize differently in designing motors and inverters?
Training. If you do not get training, an electrical engineer will not solve these problems within the decade. And the training, it doesn't take a long time. My training is 16 hours. Other people have training that lasts different amounts of times. Todd Eubing has a really good course. Learn EMC is his website. I'm not the only one that understands this physics. There's lots of us out there in Europe, in the United States. But if you don't get training, you will not solve these problems, period. You just give it up.
Let's talk about some of the other solutions. Coating the hairpin in the motors is a help, is it?
Okay, so remember I was saying that there's this 20 nanofarad capacitor that is causing all this havoc. It is a path for the RF energy to get from the super fast, super powerful transistors out into the world, okay? And it's going through this 22 nanofarad capacitor, which is really the capacitance of all of the windings added up, all right? So there's thousands of capacitors and we measure them all at the same time, and it's around 22 nanofarads, 20 nanofarads, something in that range. Okay. That's forming a resonance structure. If you put a resistor in that capacitor, you will lower the Q of that circuit. And what that means is that when the physical structure creates a resonance structure, that the resistance will keep the current down.
So all this sounds too like if you do this right, your system's going to be more efficient? I mean, if your electric motor is not radiating all this EMI and your inverter's not doing it, do they end up being more efficient?
It's more efficient for schedule because I have seen so many products that interfered with itself. They have spent, and the program was supposed to be done a year ago, and they're still trying to make the damn thing work. Why are they, why can't they get it to work? And the reason so often is that it interferes with itself, and that's why it's not working. And if you understand how RF energy propagates above 100 kilohertz, you'll understand why it interferes with itself and what to do about it. But it's all a matter of training. If you don't get the training, there's no hope.
So at the top of this interview, we were talking about how AM radio is being affected now. But as automakers go to silicon carbide chips, which they want to do,
they're doing it now.
They're doing it now. You're saying this could disrupt all kinds of other radio, especially police, fire, ambulance.
It's going to march up the spectrum. And, we've seen this happening. We're catching glimpses of it because we know, people like myself that are in the field can see it happening. I've got some Google searches that I watch things, and LED lighting, okay? Oh, my UHF radio is not working because I put new LED lighting on my boat. Well, okay, duh. A LED, when it's not conducting, is a capacitor. And it'll ring like a church bell, cause an EMC problem, and take out your UHF radio. Okay, so they turn off their lights when they want to use the radio. Well, that doesn't work very well. So how do you solve that problem? Well, you use a resistor. And if you go into the classic way of solving these problems, oh, you got to shield it. No, you don't shield it. You don't put another, inductor on it. You don't put another capacitor on it. You put a resistor on it. And that's a little bit unusual because they don't understand the physics. They think it's black magic. And they've heard from some salesman somewhere that, oh, let's put a ferrite on it and make it work. And ferrites are expensive and resistors are a lot cheaper.
Well, Joanna, I hope there's enough people in the industry watching this right now because I think it's worth saving AM radio. In fact, there's legislation in Congress maybe to mandate AM radio. Some people think that AM radio is passé. Over 80 million Americans listen to AM radio every month. I think 40 million listen to it every day. In times of emergency, it's a great way to get emergency messages out. And I especially hope that they learn from this because if it starts affecting police, fire, and ambulance radios too, we're in a heap of trouble here.
Well, everyone's moving higher in the spectrum because we're trashing out the spectrum, but it's going to catch up with us. Okay, when a noise hits the cell phones, it's going to get really ugly. Okay, because people are spending millions of dollars for spectrum. And you're going to trash out their millions of dollars worth of spectrum with your electric vehicle or your motor control for the industrial application or the pivot that you use on your farm to water the crops that are making hideous amounts of noise because they have a 1/4 mile long antenna sitting out there with water coming out of it. Okay.
So you're saying even cell phones could be affected in the future?
It's just a matter of time.
Wow. Joanna McLellan, thanks so much for your time today. Fascinating.